A perplexing and brutal industrial complex.
It's one of the most claustrophobic places on Earth.
A heavily armed giant rusting away underwater.
That shift in technology and the amount of engineering skill and knowledge that needed to be brought and focused in was phenomenal.
And one of the world's largest and most secretive weapons ever constructed.
It's almost primitive technology that's just been ramped up to as big as it possibly can.
Once they were some of the most advanced structures and facilities on the planet. At the cutting edge of design and construction. Today, they stand abandoned, contaminated, and sometimes deadly. But who built them and how? And why were they abandoned? Out in the remote deserts of Arizona is one of the U.S. Army's most important secret research sites. Standing in the wilderness is a massive single-barreled gun, dominating the barren landscape around it. At 100 feet in length, it has a huge 16-inch wide barrel, able to shoot with an unheard of 50,000 psi. It's designed to fire 400-pound projectiles over 100 miles. But why would anyone build such a huge, powerful gun? And why was it abandoned?
5, 4, 3, 2, 1, 0.
In 1961, the space race is in full swing. Yuri Gagarin gives the Soviets the first man in space. And America responds with the Mercury test rockets. And then the Apollo space missions. But at a secret test facility in Yuma, Arizona, the engineers and scientists have a challenge. Can they launch regular unmanned projectiles into space at a fraction of NASA's costs?
I had absolutely no idea that space technology was anything but the cutting edge of rockets sent up into space. But apparently not. Apparently you can revert right back to technology that is centuries old. The gun. Just get a huge charge and fire it straight up.
Using guns to put something into orbit isn't a silly idea. In fact, it's quite a cheap and reliable method, potentially, to put something into orbit. These were the early days of the space era. Technology was moving out of the Second World War and finding its use in a completely new frontier. And you don't necessarily know what's going to work. So it's much better to have the two approaches funded simultaneously, your rockets and your big guns.
This is the HARP supergun, and its target isn't on Earth. It's the edge of our atmosphere. But why would the U.S. Department of Defense, with the help of Canada, use such a huge gun to launch a projectile into space?
If you want to know conditions up in space before you send a very expensive rocket, then you can fire cheap sensors up, find out a bit about what is going on directly above where you're going to fire this big rocket. Then you're going to get some really valuable data, surely.
It was a win-win. Sure, you're going to gather all this information about the upper atmosphere. Great. But you're also going to gain a strategic military advantage, because now you're going to learn about how you can launch missiles across the world at your enemy. So that's what they were really interested in.
The HARP supergun is the brainchild of a Canadian-American ballistics expert named Dr. Gerald Bull. His aim is to make gun-fired, low-cost spaceflight a reality. But could he make this ambitious project work?
You look at what he was doing, very much the engineer, very much the scientist, always testing. When he began thinking of gun-launched technology for suborbital or orbital launches, there are a lot of people that made Jules Verne jokes about him. There were others that said, well, even if you could do that, it's worthless unless you have some kind of a telemetry package on it, transmitting data back to Earth.
He had this idea that superguns were the way to get cheap access into space, and a huge amount was learned through that program.
The target for the supergun is the ionosphere, a layer of electrically charged air that lies on the edge of the atmosphere, 40 miles above the Earth. But to reach that height, can Bull and his engineers construct the most powerful gun ever built?
Program picked up two 16-inch naval barrels. One was 69 feet long, and one was 50 foot long, approximately. And they're welded in the center and braced with the superstructure around it. Where the big bolts are right back here to the rear, that's where the two pieces were joined together and welded. They built this superstructure to stiffen, to keep them from coming apart, plus give it strength when you're up vertical. Because, you know, when you fire a gun like that, you might get a little whip and things like that, and you definitely don't want any tube droop or anything of that nature.
After multiple years of development, Bull and his engineers first test the HARP supergun on the island of Barbados in the Caribbean in the early 60s. Positioned just north of the equator, it allows projectiles to be launched into the atmosphere and then recovered from the sea. The supergun is designed to fire up into the sky at an angle of 85 degrees. But the velocity of the launch has a significant impact on the surrounding community.
There were more than 2,000 firings of this gun in the period from 1962 onward into the 70s. That is quite a lot of sonic boom, and it was a heavy boom. Barbadians felt this boom from here up to almost the top of the island. The reverberations were terrible. Houses were shaken to the foundations, and quite a few cracks in houses were reported. Barbadians felt generally that this was all to the good of the island. It seemed as though it would project Barbados into the stratosphere of world prestige.
But this ambitious project has other significant disadvantages.
As well as advantages of using a giant gun, there are drawbacks as well. So to get something to the speed that you need to get it high up in altitude, you have to accelerate it very fast. And your objects may not be able to withstand the forces, the G-forces that are experienced. And then there's also an issue of mass as well, because you can't launch particularly heavy things using this kind of technique. So you're limited to small objects.
Will the HARP supergun actually send a successful projectile into space? And why was it abandoned? In the barren deserts of Arizona, the so-called HARP supergun is an unexpected marvel of American space engineering. Built in 1961, the same year the Soviets got the first human into orbit, its ambitious aim is to launch non-manned payloads into space at a fraction of the costs of NASA's Mercury and Apollo programs. But how will this project actually collect vital information on spaceflight and the ionosphere? And will it actually work?
To get something up into space, apparently it doesn't need to be rocket science. It can be so much simpler than that, as we see with the HARP gun. It's almost primitive technology that's just been ramped up to as big as it possibly can to fire a projectile 111 miles straight up.
The projectile in question is something called a martlet, a revolutionary dart-shaped missile that is encased in the firing tube with a tight wooden ring called the sabot.
The martlet was an aerodynamic shape. Think of it as a large dart with fins. So the idea of the sabot is to fill the void of the cylinder of the tube. In this case, they use plywood, each third called a pedal. And the gases would then push this thing out the barrel. Then the pedals would fall away, and you would then have this very aerodynamic shape within the nose cone, a telemetry package, and in the aft end, the ability to eject certain materials depending on what your test was.
There is some detailed engineering going on here, but what I love about it is it's primitive technology with modern engineering applied to it to achieve something that's record-breaking, firing that projectile that high up.
Huge amounts of propellant are needed to blast the martlets higher into the ionosphere than ever before. Every firing generates colossal forces within the supergun itself. And with that comes real dangers.
You can see the massive size of this breech and the interrupted screw design that would allow it to lock in, and just the length of it just shows you the mass of this breech to be able to handle those charges and pressures that they're firing. They were looking at pressures PSI around 50,000, I think, with some of the testing.
You need to think about the materials, the size of the explosion through the propellant that you're going to use. You need to make sure the recoil's not going to just tear the gun apart, and that you've got a barrel that's long enough to project something that far up. There's a lot that goes into it, and there's a lot of thought and design that goes into achieving this. But at the heart of it, it's still very primitive engineering, and I love that.
On the 18th of November, 1966, in Arizona, the HARP supergun fires a martlet, traveling at 7,000 feet per second, 111 miles into space, a record that still stands to this very day. And using telemetry, the martlets successfully gather critical information about spaceflight and global surveillance. But because of souring relations between Canada and the United States over the Vietnam War, the HARP program ends in 1966. And today, the guns sit abandoned, a potent reminder of both the dangers of the space race and our eternal quest for the stars.
The future of space exploration may well be dependent on billions of dollars worth of investment into technologies that we don't even know about yet. I'm not saying you're going to get a man on Mars by firing him out of a gun all the way up. That's not going to happen. But if we're talking about getting payloads and objects into low Earth orbit, which could then be assembled as part of a project to then go off further and space more than we ever have done before. And it just makes me smile, the thought of that you could have this combination of technologies and of engineering eras that come together to give us something that is, well, at the moment, out of this world.
"6,000 miles away, off the southwest coast of Japan, near the port of Nagasaki, is a most mysterious place. Out in the East China Sea, this abandoned 16-acre island is 550 feet wide and just over 1,600 feet long, the length of only 4 football fields. But it has the remains of dozens of buildings and housed 5,500 people. This island represents one of the greatest engineering achievements of the 20th century. Incredibly, it's almost entirely man-made, constructed from reclaimed land.
Reclaiming land is actually a massive engineering challenge because you're working with water which moves. The levels come up and down. It can be quite acidic, quite salty. It corrodes man-made materials quite easily. And then what you're trying to do is bring stacks of new material and pile it up within this movable medium and create a solid, stable structure that you can then live and work in and build huge buildings on.
It was not called the island without green for no good reason. It's one of the most claustrophobic places on Earth. Over 5,000 people lived in a really tiny community. But the funny thing is they got used to it. And when they went onto the mainland, they felt uncomfortable. But tourists go there today, and they tell me they can't wait to leave.
But how did this tiny island become the most crowded working environment on the planet? And why was it abandoned? 1890, Hashima Island. From this half-an-acre island, Japanese engineers are trying to tap a massive coal vein 650 feet under the seabed. They drill a deep shaft down to reach the coal deposits, and it works. Over the course of the next 8 decades, Japanese energy demands increase dramatically. They eventually mine coal over half a mile beneath the sea. To meet these demands, engineers expand the island to 16 acres by the 1970s. But one thing is constant: the working conditions are unbearable.
It was a really dangerous place. Stones often fell from the ceiling. It was like doing hard labor in a steam bath.
How was this island built to sustain the millions of tons of coal extracted? And why was this marvel of modern commercial engineering abandoned? Hashima Island in Japan is one of the engineering marvels of the modern world. At its peak in the early 1970s, this tiny 16-acre island produces nearly 500,000 tons of coal a year. The mine runs continuously for 365 days a year, 24 hours a day, with over 5,000 workers sharing 3 shifts. It's hot, crowded, noisy, and heavily polluted. The increasing number of workers who come to live and work here puts space on the island at a premium. And that poses another significant problem.
I think Hashima is an incredible engineering achievement. You're talking about digging a 200-meter deep mine in the sea next to this tiny little island. And you need to think about, well, fine, I've got this mine, I've got all this material coming up, but where am I going to send it? Where am I going to store it? There's no space to actually, position it. So you have to think about conveying it out. How far can the ships actually come to the island? How are you going to get the material from the island to the ship, and then the ship can sort of disseminate it back to the country? It's an incredible logistical challenge, and I think something that they seem to have done really, really well.
What really strikes me about the island Hashima is that it's almost this self-propagating entity. The deeper you go into the mine, the more material you're bringing up. And to use that to backfill and make your island slightly bigger to maybe then house more miners so you can go even deeper, it kind of keeps going round and round. Where does it stop?
Over the years, the workforce grows massively. And over time, engineers gradually increase the massive concrete seawall surrounding the island to protect it from the storms. This makes Hashima resemble a warship. It's known locally as Gunkanjima, or Battleship Island.
When I saw the island from a ship for the first time, I had a very strong impression that the island does look like a battleship. The first thing I was surprised by was the reinforced concrete buildings. I didn't know much about the island, so I never even dreamt about seeing so many tall, reinforced concrete buildings everywhere on the island.
It's a masterclass in designing and engineering with concrete.
It seems like reinforced concrete was almost designed for something like building on a small island at Hashima. You don't have much space to move around and to bring in and have lots of stores of materials that you're going to build. So reinforced concrete's great for that. You pour it where you want it, job done once it's set. The other advantage of using it in Hiroshima is that it's pretty much fireproof. I mean, you can't set fire to reinforced concrete. And when you're dealing with a coal mine, it's probably the material you'd want best.
Though practical, the rigid and imposing architecture of Hashima Island affects the way people live.
There were so many people here. So many people that you couldn't believe it. I lived in Building 30 with my 3 other family members. We shared one room that we'd all live in together. It was extremely small. There was no elevator at all in these high-rise buildings. So people moved about horizontally. There were lots of passageways. They didn't need to go downstairs to go around apartment buildings. They moved horizontally between apartments. There was a kindergarten, elementary school, junior high school, hospital, pachinko parlor, hostess bar, barber and a florist.
Considering that 80% of our populations are going to be living in cities in the next few decades, I think there's going to be a lot more skyscrapers and height to fit all these people in. And I always imagined there to be these kind of futuristic air bridges joining buildings up so that you don't need to kind of go down and then come up again. And it's fascinating for me that Hiroshima did this decades ago. So I think that there's a real interesting model there for us to think about now.
Maybe there is an element at Hiroshima that the kind of human factor and well-being of everybody and just having some space to not be crowded and not feel so imposed upon. Just not sure that was ever considered. All they wanted to do was make it functional. Hiroshima was there to be functional. And outside of being efficient at work, I'm not sure much more was thought about.
The tight quarters especially affect the children.
Children used their imagination to play here. They played cards on the stairs, played marbles wherever they could find tiny spaces. The rooftops of all the buildings were their playgrounds. We thought carefully about how to play baseball in our own way. We used our brains a lot to play on this island.
But with the 5,000 inhabitants adapting to life here, and with 500,000 tons of coal extracted each year, why is Hashima Island abandoned? By the 1970s, the island of Hashima's population grows to over 5,500 people, all crammed into less than half of the 16-acre island, making Hashima one of the most densely populated areas on the planet, ever.
Population density on Hiroshima got to the point where it was double what civic engineers at that time would have recommended as being the maximum. So, I mean, talk about crowded. You might think you live quite close to your neighbors now. That's nothing compared to what would have been at Hiroshima.
In its 84-year history, the Hashima mine produces an incredible 16.5 million tons of coal. Its workers endure some of the hardest working conditions on Earth.
It was such hard work, no days off. So it's true to say, I wanted to leave the island as soon as possible.
But eventually, its coal deposits are exhausted, and the mining operation closes in 1974. And when the island's heart stops, its community dies too. Today, Hashima is abandoned. Aside from occasional use for movies like James Bond's Skyfall, it's mostly left to the mercy of the elements. Approximately 6,000 miles away, across the Pacific, is one of the most unusual and brash transport projects ever undertaken. In the middle of a 350-mile route that runs between San Diego, California, and Phoenix, Arizona, is a very unusual stretch. This road is made entirely out of wood. Each plank used is 8 feet long by 4 inches wide and 1 inch deep, and it runs for 6.5 miles, using thousands of wooden planks snaking through the shifting sands of the California desert.
It's a beautiful kind of American sheer audacity of taking on such a project. Yeah, why not? Of course I'm going to do it. Nothing's too much of a problem for me. A road through the desert? Hell yeah.
Deserts are very, very dynamic landscapes. You've got wind, you've got these sand dunes, and when they interact with each other, it just completely changes the surface. Things move, they get lower, they get higher. So trying to build a road on that seems like a pretty crazy thing to do.
It's almost like the simplest idea was the best. We're dealing with fast-moving, shifting sand. And when you think about a road, you think it as something solid, something that doesn't move. With the sand continuously moving, they needed something that was going to be a little bit flexible. It's a very simple idea, but maybe it was that simplicity which actually meant that it worked.
Why was this incredible road made? How great are the problems that the engineers face? And how does it end up being abandoned? In 1912, Los Angeles is the final hub of America's transcontinental railroad. But without any direct connecting routes to the east, nearby San Diego risks becoming an economic backwater, blocked by an expansive desert which is considered impassable. But local businessman Ed Fletcher demands that the Southern California Road Network use San Diego as its hub.
Ed Fletcher is one of these great unsung American heroes. He takes the initiative, he sees the challenge, and he seizes it. Let's build a road across the desert. Oh, really? How are you going to do that? Wooden planks. Is that the best idea? He does it anyways. People think California is full of crazy people. Well, you know what? Maybe they always were, but you have to admire that ambition.
Fletcher calls his novel creation the Plank Road.
We're talking about an engineering achievement here, but it's planks laid out through the desert, which is the kind of solution I might have come up with as like a 7-year-old thinking about it. But it's the fact that they laid this out, 13,000 planks, laid one after the other, after the other, after the other, which you might say, hang on, that's just not possible. For Ed Fletcher, anything was possible.
What prevents each wooden plank from moving in the shifting sands is the engineer's inclusion of the 3 metal rods. Nailed into each plank, they hold the planks together, despite constantly moving terrain. Amazingly, Fletcher's improvised road is so successful that in 1915, it's incorporated into California's state highway system.
If I'd picked up a map back then and navigated my way to San Diego and it happened to take in the Plank Road, to get there and actually see literal planks forming the road, I think I would have been extremely shocked. It's not what you'd expect.
It's completely bizarre and utterly surprising to me that 2 planks of wood in this moving sand desert can be part of a highway. I mean, it's incredible.
Despite its name, the Plank Road wasn't a joke. It wasn't just a bunch of timber laid out rustically in front of you. There was thought and process and design that went into building the road, right down to the construction technique that they used. Having a contraption that was specifically made to lay out each section of the road in front of it, which you could then roll the contraption onto to lay down the next bit in front of you. It's kind of how tunnel boring machines work nowadays, but they weren't boring a tunnel. They were building a wooden road through the desert.
For 10 years, the Plank Road is in constant use, not only by local traffic, but also by tourists who come to enjoy this incredibly bumpy ride across the desert.
Fletcher's Plank Road becomes a success because it's a novelty. It's the path less taken. It's an adventure. People want to drive on it. They know it's going to be an experience, and that's what it's all about. It's sort of the original thrill seekers. People would brag to each other, "Have you been on the Plank Road?" "I have. It's amazing." And everybody wanted to do it.
But with its popularity peaking, why is the Plank Road abandoned? The Plank Road, out in the middle of the Californian desert, is one of the most daring and extraordinary engineering projects of the early 20th century. Made out of more than 13,000 large wooden planks, this popular but rugged road stretches nearly 7 miles and forms the critical link of a 350-mile highway from San Diego, California to Phoenix, Arizona. But despite the iron railings that hold the road in place, the planks are still very susceptible to the wind and the moving sands. In 1926, San Diego businessman Ed Fletcher replaces the wooden planks with a professional asphalt surface built up on a sandbank.
Analysis was done on the moving sand, and it was found that the sands moved a lot more when it was lower. Anything that was raised up slightly was less susceptible to the moving sands. And so when the more permanent road was put in with an asphalt surface, that was put in on a kind of raised bank, whereas the original plank road was right down where all the shifting sand was.
With the new asphalt highway in place, the plank road is sidelined in the desert. It slowly disappears under the sand and is largely torn up by scavengers wanting its timbers. But Ed Fletcher shows what can be done with just a little imagination and a lot of determination.
I love the iterative process the designers and the engineers went through here, from going from the 2 parallel rows of planks that you have to keep your wheels onto, to the continuous rows of planks just laid out in front of you as a more solid structure. But you've still got planks. It's not great big slabs of concrete. Driving across that, I'm sure, in the kind of cars that they would have been driving at the time, would have made a heck of a racket and would have been quite a bone-rattling ride. I'm sure you would have been relieved to get to the end of it, whichever way you were going.
Today, the plank road lies abandoned out in the California desert. A powerful but decaying reminder of humanity's unquenchable desire to cross this planet's vast expanses to connect our cities. On the opposite side of the planet, on the southern coast of Australia, is a sunken wreck that was once at the cutting edge of maritime technology. It is 225 feet long and 45 feet wide and weighs 10,000 tons. And it's made almost entirely out of iron. Tons of iron. Its 13 coal-fired steam boilers provide nearly 1,400 horsepower, powered through 2 13-feet diameter propellers. 4 10-inch guns are on board, each weighing 18 tons, which are fired from 2 huge solid iron gun turrets.
Beauty of gun turrets is that you can rotate them pretty much 360 degrees, so you can fire in any direction. One at the front, one at the back of the ship, you're good to go. You can maneuver your firepower wherever you need it very, very quickly. For me, that's a revolutionary time in the design of battleships, because that design with the 2 gun turrets, one at each end of the ship, lasted us then for, well, decades to come.
But who built this warship, and why was it abandoned? In 1870, the Crown Colonies of Australia are just under 100 years old. As a fledgling state, vying for its place in the Pacific Ocean, Australia faces an imminent threat from a far bigger and more established country, Russia.
In the late 1870s, the Russians actually had two plans in case of war with Britain. One was to attack Singapore, the other was to attack the Australian ports. So they would have attacked Sydney, Melbourne, then headed off and hid in the west coast ports of America, which were neutral.
To defend its waters, the Australian government commissions the most advanced warship of its time, the HMVS Cerberus.
The willingness of people in the state of Victoria in Australia to put their hands in their pockets, to pay out for this warship to protect themselves against Russian attack sounds a bit nutty on the surface, but actually there was a good reason why they did that, because in 1864 the Times reported that the Russian Pacific fleet, very much a danger to shipping right across the Pacific, and therefore the purchase of the Cerberus, which was way ahead of its time in terms of military technology, this ironclad with quite powerful guns, would have played a very practical purpose to deter the Russians.
Will the world's most powerful warship stem the looming threat from Russia? And why is the Cerberus now underwater? On the eastern coast of Australia is a sunken wreck that was once at the cutting edge of design and technology. Commissioned to defend against Russian invasion, and with two huge solid iron gun turrets, HMVS Cerberus is one of the most formidable weapons ever built. It's the forerunner of some of the 20th century's most powerful and deadly battleships.
The guns are absolutely enormous. You can see the scale of the figure here. They're about 18 tonnes each.
Wow.
About 20 men were inside this in a wartime operation. 2 guns from this turret in the water on the other side, and the 2 from the aft turret on the seabed. Amazing bit of artillery.
Cerberus was the answer to the American USS Monitor. A great improvement in that she had a central superstructure known as the breastwork. This enabled the turrets to be raised well out of the harm's way of water flooding them, which is what had happened to USS Monitor. One of the advantages Cerberus had was that she could take on 490 tonnes of water, thereby lowering her profile and being a smaller target.
If you put yourself in the shoes of a naval engineer in the mid-19th century, the challenges you come up against would probably seem almost endless. It's not just changing the material of the hull from wood to iron. You've then got to think about the armour. And as you change your armour on your ships, your opponents will be changing their armour on their ships. So then you need to think about your firepower. You need to be able to pierce through their armour. That's a whole new way of thinking.
But Australia faces an even greater problem. The HMVS Cerberus is made in Great Britain. And in 1870, getting the ship to Australia is no easy feat. This iron warship, primarily designed to patrol shoreline waters, must sail a whopping 10,000 miles.
To get it there, they actually took out the guns and shipped them over separately and filled the turrets with coal. Coal in every available space on this ship to try and make sure they had enough fuel to cover the 10,000 miles. But just in case they didn't have enough, what did they have on board? Just as a little bit of extra power? Masts and sails, reverting back to old technology.
After nearly 5 grueling months at sea, the 10,000-ton Cerberus makes the epic journey from England to the far end of the world.
But it just goes to show how impressive this ship was and the engineers behind it. The war and the battle that they had to fight, not against a human enemy, but against a natural enemy. To get that ship that far, a ship that was only really designed ever to be 30, 40 miles away from a coastline. It's an impressive feat.
The Australians hope this ironclad war machine can defend its waters from the threat of the great Russian Navy. For 50 years, HMVS Cerberus valiantly guards the Australian shoreline, and perhaps, not unironically, the Russians don't invade.
Cerberus, like the nuclear deterrent today, worked very well. The Russians never came, peace was preserved, Port Phillip Head was never bombarded.
In her day, Cerberus was one of the most powerful warships out there and could easily have taken care of her contemporaries. As it happened, she never had to fire her guns in anger because the pace of technology picked up so quickly. The design of battleships moved on enormously within a couple of decades. You would never have got to where that naval technology went without the design and engineering that went in to designing Cerberus. She was part of that iterative process to get to the World War I battleships.
By 1918, at the end of the First World War, Cerberus has still never fired her guns in battle. As more advanced battleships emerge, she is no longer needed. So, what can you do with 10,000 tons of floating iron and steel? The Australians sink it and turn it into a coastal breakwater to protect the harbor.
Cerberus was lucky that it survived because it had been mothballed in Port of Melbourne for many years, and that saved it really. And then the opportunity came to sink the vessel here as a breakwater. The defender of the harbour became the defender of the coastline.
For me, Cerberus is so much more now than a rust bucket being dumped out at sea. It marks the very start of Victorian engineering and the Industrial Revolution being applied at sea in a military sense. All that knowledge and skill and drive that the Industrial Revolution had on our shores, the metal rolling, development of steam technology, all in one place that we ruled the waves with for decades and decades to come. And Cerberus there now is a reminder of that.